We're going to go deeper into a firm's decision about how much to produce, looking at all their costs. And of course, that has implications for whether other firms choose to enter a market or to exit. The baseline assumptions, talking about farms, is they're growing something that is basically a commodity. They don't really have any pricing power. For instance, if these are coffee farms, the multinational corporation can buy from another farmer. So any individual farmer has not much choice about how much they get for their beans. It's a global price. We also assume they're completely rational and not making any mistakes. So this is an optimistic assumption in that regard. In the real world, of course, people make mistakes all the time. I do. But we assume they'll figure it all out. We often find it useful to assume this general shape here in the production function, where the horizontal axis shows the units produced, Q, quantity, and the vertical axis shows dollars, total cost. The function should always be increasing, but the slope will change. We assume there's some fixed cost operating, which might be rent for a lot of farms. To produce any quantity greater than zero, this firm needs to spend some money. For a farm, that's often the rent of the land. I mean, even if the harvest is a total bust and all the plants die, they still got to pay some rent. Beyond that fixed cost, there's a variable cost. As production increases, costs increase as well. At first, costs might rise steeply, but then they flatten out for a while before steepening again, once the firm gets towards sort of capacity. We can classify all costs as either fixed, not related to the quantity of production, or variable, related to the quantity of production. Now, it's usually more convenient to look at these per unit costs. So, as we talk about dynamics, define average cost, AC, as total cost divided by the quantity that's produced, TC over Q. Define average variable cost, AVC, as the variable cost divided by the quantity produced, so VC over Q. Then marginal cost, MC, mentioned earlier, is the change in cost divided by the change in production quantity. Now, that MC is delta C, but it doesn't matter whether that's C is total cost or just variable cost, since fixed costs are, wait for it, fixed. They don't change as Q changes. So delta TC is equal to delta VC, since delta FC is zero by definition. If you've done any calculus, you'll remember that the derivative of the constant term is exactly and always zero. So the MC, the marginal cost, is the slope of the cost curve at any point. With this shape of curve, MC is initially steep, then it goes down, then it steepens again. So MC starts high, gets lower, never below zero though, and then rises again. We can see AC and AVC on this graph by drawing a ray back to the origin from any point where we want to assess AC or AVC. The slope of any line is the rise over the run. In this case, the rise is cost and the run is quantity. So the slope of the ray for AC will always be greater than the slope of the ray for AVC, any given Q. For this low amount of production that I'm showing here, AC is high because it has a very steep slope, because there's not a lot of quantity being produced. Greater production level, MC gets lower, that's the slope, and AC and AVC decrease as well. At an even greater production levels, MC starts to rise again, and AVC and AC might also rise. So how does a firm maximize profits? Well, profits are total revenue minus total cost. Total revenue, TR, for a firm selling a commodity is just price times quantity, P times Q. For instance, if coffee beans are $2.50 a pound and a farm sells 100 pounds, then revenue is $250. In a commodity market, producing firms are price takers. They just take the price as set by a large market, and they have no impact on it. on the graph, so TR is just a straight line from the origin with slope equal to the price. Now, how does a firm choose Q to maximize profit? So the profit is going to be the vertical distance between TR and TC. Look at the relative slopes of each one. If a slight increase in Q would raise revenue more than cost, that's good, would increase profits. On the other hand, if a slight increase in Q would raise revenue, but at a lower rate than it raised costs, that's bad. So the optimal point, where those two are going to have the greatest vertical distance, that'll be where the two slopes are just equal, which is where price, which is the slope of TR, equals marginal cost, the slope of TC. Now, if you know calculus, then that's obvious, but it can be useful still to understand the intuition going on here. We can see all these relationships a bit more clearly if we move from the total cost to just graphing the per unit average or marginal cost, or the price. So this will look something like this graph here. Here we see that both average cost and average variable costs start high, decline down to a minimum, and then rise again. Note the relationship between each average and marginal. Wherever the marginal cost is below the average is declining. Wherever the marginal cost is above the average is increasing, which is, of course, a perfectly obvious mathematical fact. If the last output was a bit cheaper, then that pulls down the average. If the last output was a little more expensive, then that raises the average. But that obvious mathematical fact means the intersection of MC with either average must be at the minimum point of that average, because the intersection is where MC equals average, and at the minimum point of the average, it's neither rising nor falling. It's just flat, for an instant. So with MC shown there, rising with quantity, that means the minimum point of average variable cost is going to have to be to the left of the minimum point for average total cost. That's because average total cost is the sum of average variable cost and average fixed cost. And average fixed cost, which we're not going to graph separately, is just a constant divided by Q. So as Q rises, then average fixed cost is going to get a little bit smaller. With these three cost curves, we now introduce the price, which, to recall, we're assuming is just a number. It's a horizontal line. The firm takes the market price as given. A small coffee farm in the mountains cannot impact the global price of coffee beans. One olive growing farm is not going to influence the global price of olive oil. There are giant multinational firms that buy these goods. Those have a lot more price power. But we're looking at the prices of the particular farms. Olive growers, most grape producers as well, they're price takers. The price is what it is. In this example, I'm showing the price, that blue horizontal line, is kind of high up. As we talked earlier, the firm will choose a quantity Q from where price equals MC. So that's the vertical dashed line. That's the Q that makes the price equal to marginal cost. So it's the Q that's going to maximize the profit. The other horizontal line shows the level of average cost to make that quantity. So the vertical distance between the price and the average cost shows the profits made per unit. So that big box there is the amount of profit. At that high price, firms will produce more and they'll make more profit. They'll be happy to have that price stay high, but it's not likely. That here shows a lower price. Now the lower blue line. Again, firm can maximize profit by choosing Q such that price equals MC, which is that vertical dashed line there. But note that now average cost is greater than the price, so the firm's losing money on every item sold. They're not happy about that. Why produce anything at all? Well, because the price is at least greater than average variable cost. So they're at least covering their variable cost and paying something towards covering the fixed cost. If the price went lower, below even AVC, then the firm would just not produce. Now, this might sound very abstract, but a lot of businesses do, in fact, make these sort of calculations. For instance, they decide, what time of night do we close? That last hour, there probably aren't many customers, not a lot of revenue, therefore. The business might not be covering their fixed cost, but as long as they cover their variable cost, in something like a restaurant, that would be just the cost of the people working there, then it's okay. But at some point, the number of customers falls so far the business can't even cover their variable cost, so they decide to close for the day. Of course, they might make different choices on the weekend. That's fine too. Now, why do these prices jump around? A lot of reasons, but one important one is that other firms decide to enter or exit the market. If the price is high and a lot of firms are making profits, then new firms will enter the market. That shifts the supply curve outward, which will lower the price. Or vice versa. If firms already in the market are losing money, then some will decide to exit and get out of that market. So the supply curve will shift inward and the price will rise. Now, one of the insights we'd like to take away from this is that as fixed costs rise, even if average variable costs don't, that shifts the minimum point of average cost to the right. The typical firm will get larger as fixed costs are larger. As climate change leads to farmers taking on more costs, or if, for example, a coffee farm were to go to fair trade certification or similar things, then that would tend to make each firm larger. There's a lot more we could talk about, but for now, that's good.